Video 11, Analyzing and Prioritizing Needs, BPR Model Area I MCHES Subcompetencies 1.5.1, 1.6.1. Review the learning objectives for this video. Alright, this is a really important topic, especially if you are preparing for the MCHES exam. When a needs assessment identifies multiple health problems in a community, the health educator must decide which issues to address first. This is the process of prioritization, and the Hanlon method is the most frequently tested prioritization framework on the MCHES exam. The Hanlon method was developed to bring objectivity and transparency to what can otherwise be a subjective and politically influenced decision. Rather than choosing priorities based on personal preference, organizational tradition, or the loudest voices in the room, the Hanlon method provides a systematic numerical approach. I think you will appreciate how logical this is. The method evaluates each identified health problem using 4 components. The first component is size of the problem. This refers to how many people are affected. Size is typically measured using prevalence or incidence data, population counts, or the percentage of the population experiencing the problem. A health issue that affects 200,000 people would score higher on size than one affecting 5,000 people. The second component is seriousness of the problem. This goes beyond how many people are affected to ask how severely they are affected. Seriousness is measured by factors such as mortality rates, disability rates, economic impact, the degree to which the condition affects quality of life, and whether the problem disproportionately affects vulnerable populations. The third component is effectiveness of available interventions. This asks whether proven solutions exist. A health problem may be large and serious, but if no effective interventions are available, it may not be the best use of limited resources. This component considers the strength of evidence for available programs, the feasibility of implementation, and the expected magnitude of impact. The fourth component is PEARL, which stands for Propriety, Economics, Acceptability, Resources, and Legality. PEARL serves as a set of feasibility factors that determine whether addressing the problem is practical. Each PEARL factor is rated as either a 0 or 1. If any single PEARL factor receives a 0, the entire health problem is eliminated from consideration regardless of its other scores. That is a powerful feature of this method, and it is something the exam loves to test. Now let us walk through the basic priority rating formula step by step. This is a formula you should memorize for the MCHES exam, and I am going to make it as clear as possible for you. The formula is BPR equals the quantity A plus B times C divided by 3. Let me explain each component. A represents the size of the problem, rated on a scale from 0 to 10. A score of 10 means the problem affects a very large proportion of the population. A score of 0 means it affects very few people. B represents the seriousness of the problem, rated on a scale from 0 to 20. Notice that seriousness has double the weight of size, and that is an important detail. It reflects the principle that how severely people are affected matters even more than how many are affected. Factors considered in seriousness include urgency, severity of consequences, economic impact, and effects on vulnerable populations. C represents the effectiveness of available interventions, rated on a scale from 0 to 10. A score of 10 means highly effective interventions are available and proven. A score of 0 means no effective interventions exist. Now here's why the math matters, and I think this will really click for you. The formula multiplies the sum of size and seriousness by effectiveness. then divides by 3 to produce a final score. This mathematical structure means that even a very large and serious problem will receive a low priority score if no effective interventions exist. Conversely, a moderately sized problem with highly effective available interventions may score quite high. After calculating the BPR score, you apply the Pearl factor. Pearl stands for propriety, meaning is it appropriate for the organization to address this issue? Economics, meaning is it economically feasible? Acceptability, meaning will the community accept the intervention? Resources, meaning are sufficient resources available? And legality, meaning are there any legal barriers? Each Pearl factor is scored as either 1, meaning yes, or 0, meaning no. If any Pearl factor is 0, the entire BPR score is multiplied by 0, effectively eliminating that health problem from consideration. For example, a problem might score high on size, seriousness, and effectiveness, but if it is not legally permissible for your organization to address it, the Pearl factor eliminates it. Practice a few calculations with this formula, and you will feel confident when you see it on the exam. Beyond the Hanlon method, I want to introduce you to the importance versus changeability matrix. This provides a simpler but really complementary framework for prioritization. This two-dimensional model is often used alongside or instead of the full Hanlon method, and I find it is a great way to think through your options. The importance dimension asks how significant the health problem is. Importance is determined by factors such as prevalence, severity, mortality, economic burden, and the degree to which the problem affects quality of life. Heart disease, for example, scores very high on importance because it is the leading cause of death, affects millions of people, and has enormous economic costs. The changeability dimension asks how likely it is that an intervention can actually reduce or prevent the problem. Changeability considers the strength of the evidence base, the availability of proven interventions, the degree to which the problem is influenced by modifiable risk factors, and the practical feasibility of implementing solutions. A problem is highly changeable when effective interventions exist and the primary causes are behavioral rather than genetic. Now here is where it gets really practical. When you plot health problems on a 2x2 grid with importance on one axis and changeability on the other, you get 4 quadrants. Problems that score high on both importance and changeability are your top priorities. They are significant and you can actually do something about them. Physical inactivity is a classic example. It is linked to multiple chronic diseases and is responsive to evidence-based interventions. Problems that are high in importance but low in changeability are significant but difficult to address. Genetic disorders may fall into this category. Problems that are low in importance but high in changeability might be quick wins but will not have a major impact on community health. And problems that are low on both dimensions are the lowest priorities. For the exam, understand that the ideal prioritization strategy considers both dimensions. You want to invest your limited resources where you can have the greatest impact on the most significant problems. That is good stewardship and good practice. All right, you are making excellent progress. Let us keep moving forward. Read the scenario stem aloud. Give students 30 seconds to consider options before advancing. The correct answer is B. The correct answer is B. For problem X, BPR equals the quantity 8 plus 16 times 9 divided by 3, which equals 72. For problem Y, BPR equals the quantity 9 plus 18 times 2 divided by 3, which equals 18. Despite problem Y having higher size and seriousness scores, its low effectiveness score dramatically reduces its BPR. Option A ignores the multiplicative effect of effectiveness. Option C is mathematically incorrect. Option D is wrong because BPR is calculated before applying the Pearl multiplier. Summarize the key